Hello, welcome to the second day of my C learning challenge. Just as a reminder, the idea of the project is to read the C programming language book by Brian W. Kernighan and Dennis Ritchie. And well, it's an old book, but hopefully we can learn a lot from this book. And yesterday I did the boring part, which is the Hello World program and a naive temperature converter. Yes, so this was the program that we wrote along the book. It's using a while loop where it could be using a for loop. And it's using a for loop where it could be using a while loop. Also, my mouse wheel is broken. I don't know why. Yes. So anyway. Yes, and I think the next step is converting this program to a for loop. And yes, so let me just go ahead and create a new file like this, and I'm just going to copy this program from the book. So int main int Fahrenheit, for Fahrenheit equals 0, Fahrenheit is less than or equal to 300, and Fahrenheit equals Fahrenheit plus 20, and print f 3d 6.1f \n, and then Fahrenheit 5.0 divided by 9.0 times Fahrenheit minus 32, and yep, like this. Yeah, it apparently does exactly the same in a much shorter expression, which I think is what the authors of the book were trying to showcase. And this produces the same. There are plenty of different ways to write a program for a particular task. Yeah, no shit. Let's try a variation of a temperature converter. Okay. This produces the same answers, but it certainly looks different. One major change is the elimination of most of the variables. Only Fahrenheit remains, and we have made it an integer. The lower and upper limits and the step size appear only as constants in the for statement, itself a new construction, and the expression that computes the Celsius temperature now appears as the third argument of printf, instead of as a separate assignment statement. This last change is an instance of a general rule. In any constant where it is permissible to use a value of a variable of some time, you can use a more complicated expression of that type. Since the third argument of printf must be a floating point, to match the %6.1f, and a floating point expression can occur there. The for statement is a loop and a generalization of the while. If you compare it to the earlier while, its operation should be clear. Within the parentheses, there are three parts separated by semicolons. The first part, the initialization Fahrenheit equals 0, is done once before the loop proper is entered. The second part is a test or condition that controls the loop. This condition is evaluated. If it is true, the body of the loop, here a single printf, is executed. Then the increment step is executed and the condition re-evaluated. The loop terminates if the condition has become false. As with the while, the body of a loop can be a single statement or a group of statements enclosed in braces. The initialization, condition, and increment can be any expressions. Yep. So basically this explains the way the for loop is similar to a while loop, and obviously in modern C we'll probably just include this Fahrenheit, this initial variable inside the loop, because in modern C you don't have to define all your variables before, like in the beginning of a function. But since this is a very old book, at the time compilers did require that. The choice between while and for is arbitrary based on which seems clearer. Yep. The for is usually appropriate for loops in which the initialization and increment are single statements and logically related, since it is more compact than while and it keeps the loop control statements together in one place. Exercise 1.5. Modify the temperature conversion program to print the table in reverse order, that is from 300 degrees to 0. Okay, no problem. Fahrenheit equals 300. Fahrenheit is greater than or equal to 0. Fahrenheit equals Fahrenheit minus 20. Yep, easy. Symbolic constants. A final observation before we leave temperature conversion forever. It's bad practice to bury magic numbers like 320 in the program. They convey little information to someone who might have to read the program later, and they are hard to change in a systematic way. One way to deal with magic numbers is to give them meaningful names. A defined line defines a symbolic name or symbolic constant to be a particular string of characters. Define name replacement text. Thereafter, any occurrence of name, not in quotes and not part of another name, will be replaced by the corresponding replacement text. Name, not in quotes. So this basically means that the name will actually be treated as an identifier, and it will be following all the rules you expect from identifiers. So if you enclose it in quotes, it won't be replaced because it would be very confusing. The name has the same form as a variable name, a sequence of letters and digits that begins with a letter. The replacement text can be any sequence of characters. It is not limited to numbers. Okay. So, okay. Define lower 0. Define upper 300. Define step 20. And I'm going to just go ahead and use modern C++ style comments because they're just so much easier to type. Okay. Can we get it formatted? Not what I wanted, not exactly. Okay, so int Fahrenheit equals lower, Fahrenheit is less than or equal to upper, and Fahrenheit equals Fahrenheit plus step. And now, yes, it works exactly the same as the original program. The quantities lower, upper, and step are symbolic constants, not variables. so they do not appear in declarations. Symbolic constant names are conventionally written in uppercase so that they can be readily distinguished from lowercase variable names. Notice that there is no semicolon at the end of a defined line. Yes, because they are not technically parsed by the compiler, they are preprocessor macros. So yeah, if you are familiar with C or C++, you will know it. And if you are not, you would learn it from this book. Okay. We are now going to consider a family of related programs for processing character data. You will find that many programs are just expanded versions of the prototypes that we discuss here. The model of input and output supported by the standard library is very simple. Text input or output, regardless of where it originates or where it goes to, is dealt with as streams of characters. Yeah. Many programs are just expanded okay. The model of input and output supported by the standard library is very simple. Text input or output, regardless of where it originates or where it goes to, is dealt with as streams of characters. A text stream is a sequence of characters divided into lines. Each line consists of 0 or more characters followed by a new line character. It is the responsibility of the library to make each input or output stream conform to this model. Yeah. The C programmer using the library need not worry about how lines are represented outside the program. The standard library provides several functions for reading or writing one character at a time, of which getChar and putChar are the simplest. Each time it is called, getChar reads the next input character from a text stream and returns that as its value. That is, after C equals getChar, the variable C contains the next character of input. The characters normally come from the keyboard. Input from files is discussed in chapter 7. The function putChar prints a character each time it is called. Putchar C prints the contents of the integer variable C as a character, usually on the screen. Calls to putchar and printf may be interleaved. The output will appear in the order in which the calls are made. Okay. Given getChar and putchar, you can write a surprising amount of useful code without knowing anything more about input and output. The simplest example is a program that copies its input to its output one character at a time. Okay. Read a character. While character is not in the file indicator, output the character just read. Read a character. Okay. Let's see. So what would mean? We could call it something like copy.c. Include stdioh. Copy input to output first version. No, I don't want Vimilinos. Int main int C equals getChar. While C is not equal to EOF, putchar C equals getChar, make copy. Yeah, okay. I think it only gets the char once I press enter, but otherwise it echoes the program to the console, and fgetC reads the next character from stream and returns it as an unsigned char cast to an int, or end of file on the end of file or error. getC is equivalent to fgetC, except that it may be implemented as a macro which evaluates stream more than once. getChar is equivalent to getC stdin. Okay. Okay. I remember there was one function. I think it was gets. So gets, it says never use this function. Never use gets because it is impossible to tell without knowing the data in advance how many characters gets will read, and because gets will continue to store characters past the end of a buffer, it is extremely dangerous to use. It has been used to break computer security. Use fgets instead. Okay, what's fgets? Okay, yeah, so with fgets, you can actually restrict how many files you would want to read. Great. Okay, so let's look at the program in the book. What appears to be a character on the keyboard or screen is, of course, like everything else, stored internally just as a bit pattern. The type char is specifically meant for storing such character data. But any integer type can be used. We used int for a subtle but important reason. The problem is distinguishing the end of the input from valid data. The solution is that getChar returns a distinctive value when there is no more input, a value that cannot be confused with any real character. This value is called EOF for end of file. We must declare C to be a type big enough to hold any value that getChar returns. We can't use char since C must be big enough to hold end of file in addition to any possible char. Therefore we use int. And it is defined as the maximum value of, it is defined by as -1. Okay. Great. End of file is an integer defined in stdioh, but the specific numeric value doesn't matter as long as it is not the same as any char value. By using this symbolic constant, we are assured that nothing in the program depends on the specific numeric value. The program for copying would be written more concisely by experienced C programmers. In C, any assignment such as C equals getChar is an expression and has a value, which is the value of the left-hand side after the assignment. Assignment is an okay. So in C, okay. This means that an assignment can appear as part of a larger expression if the assignment of a character to C is put inside the test part of a while loop. The copy program can be written this way. Oh, wow. Okay. Include stdioh, copy input to output, second version, and no, I don't want VM Linux, int main, int C, while C equals get char, and the value is different from end of file, put char C. Okay. Make copy 2, copy 2. So for some reason it only gets my input after I press enter. The while gets a character, assigns it to C, and then tests whether the character was the end of file signal. If it was not, the body of while is executed, printing the character. The while then repeats. When the end of the input is finally reached, the while terminates, and so does main. This version centralizes the input. There is now only one reference to get char and shrinks the program. Yep. So, the resulting program is more compact, and once the idiom is mastered, easier to read. You'll see this style often. It's possible to get carried away and create impenetrable code. However, a tendency that it is possible to get carried away and create impenetrable code. However, a tendency that we will try to curb. The parentheses around the assignment within the condition are necessary. The precedence of not equals is higher than that of equals, which means that in the absence of the parentheses, the relational test does not equal would be done before the assignment equals. So the statement C equals get char and does not equal end of file is equivalent to C equals get char. Yeah, this has the undesired effect of setting C to 0 or 1 depending on whether or not the call of get char encountered end of file. More on this in chapter 2. Verify that the expression get char is equals EOF is 0 or 1. Okay, I would actually do it. Do I have GDB? Okay, so that I'm not sure which one is actually better, but do I have lldb? lldb copy to okay, well, and then I said to put a break down on line 8. Is it possible? Copy C8. Okay, maybe I with GDB it may be easier because GDB, I think GDB is better suited for GDB copy to like this. No debugging symbols found in copy to. Okay, how do I get okay, so it's if I compile, so first CC, what is CC? CC is, I think it's GCC, right? GCC version. Yeah, it's GCC. So when I tell GCC -G, copy to C, Then when I open GDB copy2, I'm getting copies. I'm getting the actual symbol. So now I can say break on main.c line 8. No. Okay, once again, break on copy C, copy2.c line 8, and then run. And then I'm reading the first char. And now, what can I get? What's in the stack? A list of classes of commands. Help stack. Okay. Frame view. Missing address argument to view a frame. Okay. What do I have in data? Help data. No, okay. What else do I have? Because I want to find a command that will tell me what the value of the variable is, but I don't really have any variable, so I will have to do something like this. I would have to do something like this. Well, int equal, like this. Okay, int equal, like this, and then equal. What does it say? Using the result of an assignment as a condition without parentheses. Okay. Okay, so I just have to add even more parentheses. This is becoming very much this is becoming kind of lispy. Okay, compile again, GDB copy, break on copy to C line 9. Okay, run. And now, and what do you have in history? Examining the stack, support tracepoint user defines internals. Help internals. Print symbols. Yeah, I'll just ask GDB print local variable. Info variables. Okay. Info locals. Okay, so now, well, you may notice that I ran the program and I typed AOE, and then I pressed enter, and then we started getting actual input in the put char. So now in the first iteration we're getting C, which is 97, and that's the code of a lowercase a, and then I get the equal. Okay, so continue. And now info locals. Now you have 111, which should be O. Continue. Info locals, continue. Okay, so now what do we have now? What's 10? Okay, so 10 is a new line. Continue. So now we got, okay. And now if I press Ctrl Z, that's okay. We got received signal stopped by user. So we are not going to get any information because we are not going to get any information about what happens afterwards because we're not going to get any information about what happens after I output an end of file because that causes the program to stop, to terminate. Seek TSTP. What does this mean? Okay. Okay. It's called man 7 signal. Overview of signals. Linux supports both POSIX reliable signals, hereinafter standard signals, and POSIX real-time signals. So seek the stop type at terminal. So that's what happened. I typed Ctrl Z and we got seek TSTP signal stop type at terminal. Okay, that all makes sense. Anyway, we confirmed that the variable equal in here is equal to 1 because, and that's why the condition continues evaluating. My streaming machine is, my recording machine is getting very hot and very loud. Okay, so this is done. Write a program to print the value of end of file. Yeah, we could do it, but I already have I can just see it using I could just see the value using the LSP, or I can write another program, include stdio int main yes, printf %d end of file. Okay, let's see. Make EOF. Yeah, it's -1. But why does it say it's why is what is the binary representation of -1 actually? Is it actually 4 like because this looks like it would be the maximum value of the UI of like the I would have thought that this would be the maximum value of an integer, but apparently it's not. Okay. Write a program to print the value of end of file is -1. Character counting. The next program counts characters. It is similar to the copy program. Okay, count characters in input. Include standard IO. Int main long nc equals 0. I'm just going to directly initialize it here. While get char is not equal to end of file plus nc, and then printf %ld and nc. Okay, so you probably you're already familiar with the plus plus operator. It's basically it basically increments the NC number, the NC variable, and make count. Okay. Yeah, I don't really know how to type an end of file. Oh, I guess it's a Control D. Sorry. Okay, yeah, it's Control D. So okay. Yes. So this statement plus plus NC presents a new operator plus plus, which means increment by 1. You could instead write NC equals NC plus 1, but plus plus NC is more concise and often more efficient. Where was I? There is a corresponding operator minus minus to decrement by 1. The operators plus plus and minus minus can be either prefix operators or postfix. So this means that they can be the operator can be put before the variable and after a variable. These two forms have different values in expressions, as will be shown in chapter 2, but plus plus NC and NC plus plus both increment NC. For the moment, we will stick to the prefix form. The character counting program accumulates its count in a long variable instead of an int. Long integers are at least 32 bits. And what is it here? Okay, I don't know what NC is. Although on some machines int and long are the same size, on others an int is 16 bits with a maximum value of 32,767, and it would take relatively little input to overflow an integer counter. The conversion specification %LD tells printf that the corresponding argument is a long integer. It may be possible to cope with even bigger numbers by using a double precision float. I think we could use long, but we are not going to get to 4 billion characters. We will use a for statement instead of a while to illustrate another way to write the loop. Okay, now this is crazy. Count to C. Include standard input IO, int main, double, and C. Okay. For double and C. No, it has to be outside of the loop. For and C equals 0, get char is not equal to end of file plus plus and C. Printf 0f and NC. Okay, %.0f suppresses printing of a decimal point and the fraction part, which is 0. Yes, because we are only going to increment it. Like so, make count 2. Yep. Works exactly the same, I guess. The body of this for loop is empty because all of the work is done in the test and increment parts. Yep. But the grammatical rules of C require that the for statement have a body. The isolated semicolon, called a null statement, is there to satisfy the requirement. That requirement, we put it on a separate line to make it visible. Okay, yep. Could I just use an empty block? Yeah, that looks more like something I would write. Before we leave the character counting program, observe that if the input contains no characters, the while or for test fails on the very first call to get char, and the program produces 0, the right answer. This is important. One of the nice things about while and for is that they test at the top of a loop before proceeding with the body. If there is nothing to do, nothing is done, even if that means never going through the loop body. Programs should act intelligently when given zero-length input. The while and for statements help ensure that programs do reasonable things with boundary conditions. Line counting. The next program counts input lines. As we mentioned above, the standard library ensures that an input text stream appears as a sequence of lines, each terminated by a new line. Hence, counting lines is just counting new lines, okay? Int C and L, okay? So I will call it WC because that's what the actual corresponding program is called. Int main, int C, new lines, okay. And L equals 0, while C equals get char. Is not equal to end of file. If C equals new line plus new line, and then at the end print f %d_n and L. Okay, I guess I could just pass some input. So I could pass the input of the actual source file. And what if I counted the character counter? Yep, looks legit. The body of a while now consists of an if, which in turn controls the increment and L. The if statement tests the parenthesized condition, and if the condition is true, executes the statement or group of statements in braces that follows. We have again indented to show what is controlled by what. Yeah, you can indent, or you can just use curly braces like a human. So much hurt. The double equal sign is the C notation for is equal to, like Pascal's single equal sign or Fortran's.eq. This symbol is used to distinguish the equality test from that single equals that C uses for assignment. A word of caution: newcomers to C occasionally write equals when they mean equals equals. As we will see in chapter 2, the result is usually a legal expression, so you will get no warning. Yep, and it's a perfect place to put backdoors. A character written between single quotes represents an integer value equal to the numerical value of the character in the machine's character set. This is called a character constant, although it is just another way to write a small integer. So for example, capital A is a character constant. In the ASCII character set, its value is 65, the internal representation of the character A. Of course, A is to be preferred over 65. Its meaning is obvious, and it is independent of a particular character set. Yep, so even up to this day we will be getting ASCII is kind of the standard, because right now everybody should be using UTF-8, and UTF-8 is a superset of ASCII. The escape sequences used in string constants are also legal in character constants, so single quote \n single quote stands for the value of a new line character, which is 10 in ASCII. You should know that carefully that \n is a single character and in expressions is just an integer. On the other hand, double quote \n double quote is a string constant that happens to contain only one character. The topic of strings versus characters is discussed further in chapter 2. Okay, write a program to count blanks, tabs, and new lines. Okay. Okay, blanks. Include stdio int main. Okay, so I'm going to be using int c and yeah, I could be using more local variables, but in general long uint 32 include stdint.h uint32t blanks, tabs, blanks equals 0, tabs equals 0, new lines equals 0, while c int c while c equals get char is not equal to end of file, switch c case new line no lines plus plus. Oh yeah. Case tabs plus plus and case space. I guess that by blanks I mean spaces. Blanks plus plus default nothing. Oh yes, and since this is C, we need to use breaks after each case branch, otherwise we will get fall through. Okay, and we don't need I don't think we need I'm not sure if we have to include a default branch. Let's see. Printf blanks printf tabs and printf new lines, and we probably have to include this ld, even though, oh yeah, well, wait, so ld format specifies type long, but the argument has type unsigned int. Yeah, okay. So it's uld? No. What does that? Okay, so okay, let's see. I'm truly not sure. Make WC2, cut WC to C2 and pipe it to WC2. Does it make sense? Yes, we have 27 new lines. We have some tabs, definitely. We do have some tabs, oh yes. And we have some blanks between them. So it looks like it checks out. And I have forgotten to add a new line in here. Okay, great. Write a program to copy its input to its output, replacing each string of one or more blanks by a single blank. Okay, yes. So that would be WC3C. Include stdio. Int main. Int C. While C equals get char is not equal to end of file. C equals okay. Int C and C equals, I just initialize them. Int C equals 0 and last equals 0. So my idea is that I'm just going to check if the previous character read was a space, and if it was, we just do not output a space. Or I could just do something like bool include std bool h bool last character was blank equals false, and now if C equals n, if C equals S blank, okay. If C equals a blank and not last character was blank, put char C equals blank and last character was blank, we don't do anything. Continue. And then put char C last character was blank equals C equals this. Okay, I'm not sure if this is going to work. So cut WC3 put C and pipe it to WC3. Okay, so in here it doesn't seem like we actually have any multiple spaces, but let's see what would happen if I intentionally added some more spaces, like in here. Yep, so it seems to work, because if we cut this this file, we see that there were some multiple spaces in here, and our program just did not output them, which means it is working as intended. Write a program to copy its input to its output, replacing each tab by /t, each backspace but by /b, and each backslash by double backslash. This makes tabs and backspaces visible in an unambiguous way. wc4.c include stdioh int main in C while C equals get char is not end of file. Switch C case /t put char now we need to use printf or puts no okay put okay, yeah, we have to use printf because puts would output a new line like this. Break case /b printf /b case /printf break and default put char and okay, yeah, we don't need, and let's see, make wc4 cut wc4.c to wc4. Yep, looks legit. Okay. Yeah, so we've been coding for almost an hour, and my goal is to to do this for an hour every day until I get bored, or until we finish with the book. But actually I was expecting the book to be obsolete or boring or not challenging enough, but even though I've been writing software for several years, I actually do think this is quite challenging, and it does contain a lot of pretty good exercises. So by any means, if you have some spare time and want to learn C properly, then this probably is a decent way to do it. And in the next video we will do this word counting exercise, and there will be a lot more arcane syntax. So I probably will put the source code for these exercises in a Git repository, and I will put a link in the description under the video. And if you have enjoyed this one, please like and subscribe, and if you did not, please let me know what you didn't like, and I will probably just ignore it because I don't care about your opinion. No, that was a joke. Please like and subscribe, and I will try to do whatever I can to make you happy, I guess. Yep, so see you in the next one. I hope you learned something.